All right, well, I think we can get started. So welcome back, everyone. This is the second installment of the Quadrotor workshop hosted by McGill Academy, as mentioned in the previous video, and all of our other ones. I'm Nima Hamadi. I'm the president and the workshop coordinator for this club. And yeah, today we're going to be essentially extending off of what we did in the previous session, which was creating a chassis. And in this particular session, we're going to be creating the arms of our Quadrotor. So what I'll do is I'll first show how to individually CAD the component. And then from there, we can plop it into our assembly and also use some of SolidWorks' more snazzy tools that make life a bit more convenient to show that you can easily connect these two components together without any fuss or hassle. Awesome. So let's get right to it. So I'll just share my screen over here. Give it a moment. Cool. And as mentioned previously as well, I've got a bit of a weird overlay happening with SolidWorks at the moment, notably with this sort of blue window here. And that's because I have my reference part open in my second monitor, just to ensure that the fits and tolerances are the same and that we don't waste a lot of time just going back to the previous file and looking back and forth. I've essentially got two part files open at once. So if you're ever wondering why I'm looking over there, that's why. But that's enough chatter. So like always, whenever we're starting a part, let's start by creating a sketch, right? And usually it's more convenient to just start off with the top plane. That's just a personal preference of mine, but it often depends on how you visualize it in your assembly as well. From there, now I want our arm to sort of have this rough shape. So I'll demonstrate by essentially drawing a few very arbitrary shapes. They don't have to be defined by any means. So we'll give it a bit of a radius as well. Why not? And then let's also draw a circle at the bottom. Now, this is sort of the rough idea I have in my mind for how it should look, right? So essentially, this top arc is where I want our arm to connect to the rest of the chassis. And from here, this is the base of the arm. And at the bottom here, it needs to support our propellers somehow, right? Without propellers, we won't be able to fly our Quadrotor. So essentially, what you're going to have to anticipate is one hole up here for essentially bolting our arm to the chassis itself, and another hole down here for the propellers. Now, let's go and iron this up a bit, because right now, we're not really going to get anything that's going to fit into our assembly with this current part. So what I'm going to do is I'm actually going to add some definition to the sketch we have right here. So we can do that by two methods. Like I mentioned, you can either put in dimensions. So essentially, we can define the length of this. And note that I'm in IPS units, or inch pound second units. So let's say this is 7 inches long, the width or the length of this rectangle. Furthermore, we can also assign it a position relative to our coordinate axes as well. That's another way of establishing where we need our parts to be or providing definition. But typically, for when it comes to positioning and constraints related to positioning, I like to use relations. So if you click on this origin, and if you shift click on the midpoint of this line, you can press horizontal, and you'll notice it's shifted down, and we've actually fully defined these top edges, meaning the file essentially knows that both of those edges have to be 3.5 inches away from the origin, at least from a, in this case, Z-axis standpoint. As well, we can do the same for the top edge as well. So we'll shift click and press vertical, and there we go. Now you'll notice it's not fully defined along the sides here, and that's mostly because we haven't specified a width for our part here. So we can do that very easily. So in my part, I essentially defined it as 2 inches for the overall width between these two components. So we can do that right here. So I'll switch to this monitor and press Smart Dimension, click on both of these edges, and then we'll give it a nice width of 2 inches once my computer cooperates. My apologies. Cool. In addition, I noticed that this arc, while it could potentially work for the part we have, if you sort of imagine if we want to draw a hole here, so if I zoom in, we'll essentially have this amount of vertical space to put our hole into our sketch, which it could be adequate. But if we want to give it a bit more space, what we could do is we could actually delay when this arc shape starts to happen relative to our base. And that's exactly what I'm going to do. So what I'm going to do is I'm going to get rid of this arc now that we've established the idea of what we want. And from there, I'm just going to draw another rectangle. So we'll give it the same width as our base. And essentially, we'll say that this is an inch away from our base, right? So give that a moment, and we'll say 1 inch. Cool. And then from there, we'll draw our arc on top of this new shape. And now relative to what our original specifications were, we'll have a lot more space to put the hole for our chassis compared to what we had before. So what I'm going to do is I'm going to actually go and constrain the origin of this arc, or sorry, the arc center, to the midpoint of this particular shape here. So we can press coincident. There we go. Now you'll notice that in terms of our contours, we have, these shaded in contours over here, but up here, it's not shaded anymore. And that's mostly because SolidWorks typically likes to sort of define its inner contours, or essentially it chooses which contours it shades in, and then anything outside of that, it essentially omits. But for our purpose, we want this to be one composite solid part. We don't want this. We want these two components to essentially be shaded in, so the base and our arc. So the way we can address that is by changing this particular portion. By right-clicking it, we can change it to construction geometry. So essentially, it's a line that is defined and could be there, but it actually doesn't affect what the contours look like when we go to extrude or revolve later on. And we can do the same for this one underneath as well. Press construction geometry, and you'll notice there was two because, again, we drew two rectangles on top of each other, but that doesn't really matter. Cool. And then from there, what I'm going to do is I'm just going to draw the hole for our particular chassis. Now, the way I have it defined is, I believe, 5/8. It's a 5/8 hole. So what I'm going to do is I'm just going to give it a dimension of 5/8. In reality, whenever you're doing some sort of engineering project, or if you have many holes you got to put in, typically it's easier just to use the hole tool. But for this sort of CAD tutorial, I'm just going to go and manually define our hole. Cool. And I'm not going to add any threads as well, just for the sake of computational power. And now what's left is this circle here at the very bottom. So there's a couple different steps to achieve this sort of shape that we want to desire. So we can work on that from here. So what I'm going to do is I'm actually going to define the circle as being vertically aligned with the origin. So we can do that. And in addition to that, what I'm going to say is that the circle itself is, let's see. We'll say that it is, 1 second. My computer's frozen a little bit. Cool. Let's see. We'll put it at 1.5 inches for now in terms of the diameter. And I'll also change this along the way. That's another thing with CAD is you're typically changing on the go, and you just have to make sure that it ultimately ends up emulating what you want it to emulate. There's that so far. Okay, perfect. Oh, but I've written it as a 2-inch diameter. My apologies. Here, we can change that. See, these are the struggles when you're working with multiple files at once. There we go. We'll make it 2 inches. And then what I'm essentially going to do is have this particular circle be 7 inches apart from our origin. And if you're wondering again where I got these dimensions from, they're already from a part that I've created. Usually when you're in the engineering context, you have a set of dimensions and possibly even a drawing to refer to. For the context of this, I'm going off of my previous work. Okay, now what I'm going to do is I'm going to create another circle around this, and we'll give it a diameter of 4 inches. Cool. And now you'll see that these two, if we're talking in terms of radii, so this is going to be a 1-inch radius, and this one's going to be a 2-inch radius. So they're going to be an inch apart, essentially. And now we need to find a way of connecting these circles to the rest of the arm, essentially. But we want to do this in a pretty nice, streamlined way where the parts are essentially merging into one another. So what we can do is we can actually draw 2 lines. So I'm going to draw a line from this corner piece, and I'm essentially going to have it such that it's just floating like this, right? And then I can click on the line, shift click on this circle, and then from there we can click the tangency relation. And now you'll say, okay, that's cool, but we have this sort of excess line remaining. What are we going to do with that? Well, we can simply just trim it off. There you go, and it's fully defined. We'll do it on the other side as well. Give it, any sort of length you want. It's up to you. Shift click on the circle, and then we'll give it another tangency relation. Awesome. And then we'll trim the excess off. Cool. Now you'll notice the contours aren't quite shaded quite yet. And the way we can address that is by trimming this excess right here. So if you sort of think about it from like a holistic standpoint, we have 2 different objects sort of preventing this from being one singular closed contour. And that is this line right here and this line, this arc right here. So if you'll notice, if I trim this arc, we've opened up another contour, but there's still 2 separate contours. We have this shaded portion and this unshaded portion. And you'll also notice that we've already established a dimension with this existing line, so I don't necessarily want to get rid of it, So what I can do is I can keep it as construction geometry like we did above. And then from there, we essentially have this shape. Now you'll see it's got 2 different contours that are shaded as so, but trust me, when we extrude, which we'll do right now, it'll all look like it's coming together. Cool thing. So, all right. And then from there, we're essentially good to extrude. So we can do that as such. We'll press extruded boss / base. Give it a moment. There we go. And you'll notice it's automatically selected the contour we want, but we can also do that by clicking the selected contours box right here and clicking on it manually. Same sort of effect. And we'll give this a 2.5-inch blind extrude. So essentially we're assigning it a length, but there's different ways to extrude as well. Cool thing. And there we go. It's starting to come together. As you can imagine, on this end, the chassis will be connected to our arm, and this end will house the propeller. Awesome. Now from there, what we can do is we can make this look a little nicer and get rid of all these stress concentrations in the middle by adding a set of chamfers. So what I'm going to do is I'm going to chamfer this edge, this top edge as well. You'll notice it's not previewing anything because this chamfer is actually too large for the object. Let's reduce it to 0.25 inches. And also, if we have that one selected, it's not going to chamfer properly. But if we deselect it, it's perfectly fine. And we'll also do this for the hole underneath. But I'm going to select a different chamfer for the bottom edge because I was having some interferences before with having the same chamfer. So this is probably a bit more a bit better for the assembly ultimately. So I'm going to go and say this is 0.125 inches and chamfer this bottom edge. Cool. And if we press OK, we have our chamfered object. I realized that actually that these two armholes that we have on the end here should not have been chamfered. So I'm actually going to get rid of those. I'm talking about these guys. So let's go back, because it's going to be a very weird countersink. Okay. And instead of choosing the face, what we'll do is we'll actually choose the edges. Okay. Bear with me here. Cool. That's better. And then we'll do the same on the bottom as well. Oh, it's already done. Cool. So we selected the bottom perfectly then. Awesome. Now from there, what I'm going to do is I'm actually going to make a small little cut on the side. So right along the side where the chassis is going to end up being. And from there, that'll actually allow us to put in the little stump that we made last time in between the two sort of teeth of our, what do you call it, of our arm here. So let me just refer to the dimensions I had before. So 2 inch, 1 inch, and 1.25. Gorgeous. So what we can do is we can create a new sketch. And this time what we're going to do is we're going to put it on this right plane here. We want it to be smack dab right in the middle. Cool. Now I'm going to project to this plane, or project our view. Oh, sorry, my apologies. Let's just use the manual clickers this time. Awesome. And then from there, I'm going to just draw one simple rectangle. Cool. And I essentially want it such that it is the center point of the rectangle is 1.25 inches or halfway down from the top of our object. Cool. And then we'll also specify the width of the actual selection itself. So let's say it's going to be 1 inch wide. Awesome. And then we got to specify a length. So we'll give this a length of 2 inches. And now what we're going to do is we're actually going to use this to cut. So if we go back to the features and we click extruded cut, give it a moment. There we go. Now you'll notice it's only going to want to cut in one direction automatically. You can enable a second direction if you want, or you could simply just click through all both, and it'll automatically select the second direction for you, and it will go through everything in those two directions. So if we press OK, cool. We have our cut as shown here. Now, typically, also, if you want, you could put in an additional arc right here, such that you're avoiding the stress concentrations, because this isn't necessarily the most manufacturable part. If you can imagine sort of a milling head trying to go through there, it's not going to be ideal. But, you know, for the sake of this tutorial, I just wanted to show you guys how to essentially create this rough shape. And then from there, any sort of details that you want to add, feel free to add those on your own. Okay, awesome. So this is almost ready to put into our assembly. I'm also just going to go and quickly change the color as well, just because it's pretty snazzy that way. So I'll click this little feature setting up here, appearance setting, and it's on my other screen right now. I'm going to drag it on over so you guys can see what I'm talking about. And we can apply a myriad of different colors, right? Now, this is probably going to be some form of plastic because it's just a toy quadrotor. And we'll just give it, let's say, a high gloss finish. Perfect. And we've already selected the part entirely. We don't really have any composite parts that we want to change to different colors, but if you want multiple colors within your object, you can essentially go and click these multiple options. So say, if you want the whole part to be one color, you click select part. If you want a particular face to be a color, you select face, and then you click on each one individually with your desired color, and so on and so forth. If you have split bodies and features, so on. But we'll keep it as is. And there we go. This part is essentially good to go, and we can actually put it into our assembly. So I will come back once I have this saved and our assembly open. Okay, cool. So I've got the chassis open now. And what I'm going to do is I'm going to make an assembly from this part. Okay. So we'll just give it a little moment. Computer's being a little slow. And give it a little bit. Yeah, Zoom takes up quite a bit of my RAM. So there we go. And then what we're going to do is we're going to insert some components. Now, this updated chassis is already open, so I'm going to go and click on that and click in. There we go. We've pasted that in. And then here's the moment of truth. We're going to insert some more components, the components being our new arms. So if we go back, it's Quadrotor Workshop, and I have this arm right here. There we go. We have this component. It's ready to go. And then from there, what we have to do is we got to put everything together. So you can use the mating tool to accomplish this. Now the chassis, as you can see, has this little F in parentheses, indicating that it's fixed. So SolidWorks does this with the first part that's being placed within an assembly. It fixes it such that everything else is essentially referenced about that object. Now what I'm going to do is I'm going to go click on this face here, and we're just going to mate it with the underside of this face. And essentially mating is, as the name insinuates, applying some sort of 3D relation between two different objects. So essentially in this case, I want a coincident mate, meaning that the planes of these two objects are coincident. They don't necessarily have to be touching in all axes, but along, let's say, these are each along the Y plane. They have to have the same height, essentially. So we'll press OK. And they have to be parallel too. That's another thing with coincident mates. And then from there, we can click on this face right here and essentially go underneath and establish a concentric mate. There we go. And then there you go. You see, you have your arm selected. And then from there, if we close the mating tab and try to move this arm, you'll notice you have your one singular degree of freedom, which is about the Y-axis. This is awesome. Now, the moment of truth is when you have to check for interferences. So SolidWorks has a nifty little tool that allows you to do that. So when you click on it, if I go to the Evaluate tab and Interference Detection, it automatically, once you press Calculate, goes and looks throughout the entire assembly and sees if there are two different parts that are occupying the same space. And if they are, meaning that in real life they'd be colliding, it lets you know. So let's see. No interferences. That's what you love to hear. This is perfect. Now, if you want to make your mates a little bit more advanced as well, what you can do is you can actually limit the amount of movement that this arm has. Because say if I want to rotate this around, but I accidentally go that way, right? You see it's interfering with the actual chassis itself, which again is not something you want, especially if you're presenting this to someone. So what you can do is you can establish a new type of mate. So we can go to the Mate tab again. And from there, what we can do is press Advanced Mates. And you see where it says this limit angle. If you click on it, it gives you an upper bound and a lower bound, right? So it gives you a range of different angles you can mate this arm along with. And there's also one for distance as well. So what I'm going to do is I'm going to click on the face of this, and I'm going to click on the face of our reference object. Or actually, we'll click a different face. Sorry, that face is not good. We'll go with this face right here. And the reason why I clicked on that one is because ideally you want it to be either parallel or perpendicular as your maxima or minima. So from there, I'm going to say this is going to be automatically at a 90-degree angle with respect to our wall. So that's totally fine. And then for our maximum bound, we'll say you can only move this arm around, let's say 180 degrees, although it could interfere with the other arm on the other side. So maybe you want to reduce this a little bit. Say the max you can go is, let's say 120 degrees. Why not? And then if we rotate this to the 120-degree mark, you'll notice it's a little bit in front. It's not quite going to interfere with anything else, and you'll still get your full range of motion. And for the lower bound, we'll say 0 degrees, aka they're parallel. So if we go to 0 degrees and type that into our current position setting, that's what you're going to get. So if we press OK, you'll notice that if we try to rotate this arm, it will only move between these two settings. How awesome is that? Cool. And I don't believe, yeah, we don't have any interference off that yet. That looks very close for a moment there, but luckily that is nothing. And physically, it wouldn't make sense if there was interference. Now, the next thing we have to add is fasteners, right? And SolidWorks helps you with that too. So what you can do is you can go and click on this tab, or sorry, the SolidWorks Resources tab, right? I got it wrong again. The Design Library tab, there we go. And then click on Toolbox. So this is an add-in I've put in before. And essentially, it's not currently added in, but if I press add in now, it'll load it in for you. And then from there, if I essentially go and collapse this to our feature tree, or the other side of our feature tree, you'll see it gives you a full set of toolboxes for different types of standards. So in this case, we're going to stick with ANSI inch. And it gives you bearings, bolts and screws, jig bushings, keys, nuts, O-rings, whatever you want, even gears as well, which is pretty nice. But we're going to stick with bolts and screws. And if you remember, we set a diameter of 5/8 inches for our hole. So I'm just going to go and choose a random, let's see, what type of screw do we want? Let's say a round head screw. There we go. A round head bolt. And we'll just slide it in here. So drag and click until it is essentially concentric and coincident with this plane right here. I may have chosen the wrong bolt here because ideally you'd want some sort of socket head, but let's just forget about that for now. So we want the size to be 5/8, 11. And then you can check if you have the right size by if you extend the length of this bolt, you see it is perfect to the size that we created. So we'll say the length is going to be approximately 3 inches, such that it doesn't protrude too much. Cool. We'll actually keep it at 3.25 because ideally in the real world, you'll want a couple of extra threads for your bolt to actually, or for your nut to actually hug around, such that the bolt doesn't fall apart. And then you'll see once you've loaded in your first component, you can do this for multiple arms. But for the sake of this assembly, you know, we're only going to do one arm, and then I'll leave the rest to you. So in addition to a bolt, we'll also need a nut. So what I'm going to do is I'm going to go back into our toolbox and click nuts. And then we'll simply go with, ideally you'd want some sort of nylock nut, but we're going to go with a hex nut in this case. And we'll just put a hex jam nut. And then there we go. We essentially have it such that it's concentric and coincident. There's a little circular cylinder symbol touching a plane that pops up in that case. And we'll say the size is, as we've demonstrated, 5/8, 11. Cool. And if we press OK and exit out when it asks us to place another nut, you'll notice that if we want to move this nut, it is perfectly constrained. This bolt is also perfectly constrained if I shift or drag and click. And then within this assembly, we can move this around. Ideally, I would just change the type of nut here. This is not the greatest nut. Also, if you imagine from an assemblability standpoint, you'd want something with a smaller socket size. But essentially, that was just to demonstrate the power of the toolbox. So I'd recommend playing around with it, seeing what best suits what you want. And then from there, also, you could change the arm design. You could change the chassis design to satisfy your needs. But that's essentially the second part of the tutorial. I'm glad that you tuned in, and I hope you got something from this. So thank you so much. Take it easy.